Every hard drive inside your computer is a physical mechanism living on borrowed time. When a drive eventually fails, years of family photos, crucial work documents, and irreplaceable digital files can vanish in an instant. You can prevent this loss by linking multiple hard drives together into a single storage pool. Windows includes built-in tools that allow these separate disks to act as a unified, resilient volume. Setting this up requires a specific hardware baseline. You need at least 2 empty drives installed to create a mirrored backup, or 3 empty drives if you intend to use a parity configuration. Before you begin, understand that this process will wipe the drives you add to the pool. Ensure any existing data on those secondary drives is moved to a separate location first. By configuring redundancy at the software level, you transform standard consumer drives into a storage system capable of surviving the death of a physical disk. The first step is bringing your raw hardware online. Press the Windows key and the letter X at the same time, then press K to launch the Disk Management utility. This dashboard shows every storage device connected to your machine. Your main operating system drive has a blue bar over it. Your newly installed empty drives will sit below it, marked with solid black bars and labeled as unallocated. Right-click the label for each of those new drives and select Online. Next, right-click them again and choose Initialize Disk. Select the GPT partition style and click OK. Check the disk labels again. They should now read Online, and the black bar area should say Unallocated. Do not create a new simple volume here, as we will be grouping these drives in the next step. Initializing these disks is a mandatory requirement. Now that the operating system can officially communicate with the raw hardware, Windows can begin the process of pooling them together. Click your Start menu, type Manage Storage Spaces, and open the application. Click Create a new pool and storage space. Windows will detect the drives we just initialized. Check the boxes next to each disk you want to include and click Create Pool. Now you must choose how Windows protects your data. Under the Resiliency Type menu, you will see several options. These replicate traditional RAID configurations, methods of distributing data across multiple disks using software logic. Two-way mirror writes every file to both drives at once, ensuring an identical copy. Parity distributes files across 3 drives, calculating and storing redundant data alongside original blocks. Note, usable space is limited by your smallest disk. Extra space on larger drives becomes inaccessible. Assign your new drive a letter, select Parity from the menu, and click Create Storage Space to format the unified volume. Finalizing this setup creates a permanent software structure that determines the balance between your available storage capacity and the security of your data. Open File Explorer. You will see that the individual physical drives are no longer listed. In their place is a single drive letter representing the total capacity of your storage pool. To test the system, copy a video file onto this new drive and begin playing it. While the video runs, return to Disk Management. Right-click an active disk in your array and select Offline to simulate a hardware failure. Look back at your desktop. The video continues playing without interruption, even though one of the physical disks supporting the file has been disconnected. The degraded warning in your Storage Spaces dashboard confirms the test was successful. The software logic is now reconstructing the missing data in real time to keep your files accessible. To recover from a real failure, you must replace the dead hardware. You would power down the system, remove the failed drive, and connect a blank replacement disk of the same size. In the Storage Spaces menu, click Add Drives to include the replacement disk in the pool. Then, locate the entry for the failed drive and click Remove. Windows will start a background process labeled Repairing. It uses the surviving data and the parity information to rebuild the missing blocks onto your new replacement hardware. You have achieved reliable data protection using built-in software. This configuration provides resilience against hardware failure without the need for specialized RAID controllers. Mechanical drives are guaranteed to fail eventually. By building this software architecture now, you ensure that a hardware breakdown does not result in the loss of your data.